Lesson 2.2, the distributive property. Equivalent numerical expressions are numerical expressions that have the same value. Equivalent variable expressions have the same value for all values of the variables. The distributive property says that if you have a number being multiplied next to parentheses with two numbers that are being added together, then you can take the number that's being multiplied and multiply it by each number inside the parentheses. So it becomes 4 times 6 plus 4 again times 3. No matter where the multiplication is, you can do this for any number as long as there's an addition or subtraction sign inside the parentheses. So here's the 4 that's being multiplied because it's next to parentheses. I can multiply that by the 6, put the addition sign in between, and then do 4 times 3. Again, the order of the numbers do not matter because of the commutative property. The same holds true if there is subtraction inside the parenthesis. The number that's being multiplied on the outside can be multiplied or passed out to the number inside the parenthesis. So I can do 5 times 7 minus 5 again times 2. And then 5 times 7 minus 5 times 2. Let's take a break from the note-taking guide for a second and talk a little bit further about the distributive property using a Prezi slide show. The distributive property sounds sort of complicated. It's not really, though. Let's say you have a problem like this. How would you solve it? You could add the 2 and the 8 in the parentheses and then multiply by 5. We use the distributive property. Let's start by looking at that problem again. The distributive property says we can take that 5 and multiply it by the number in the parentheses. The only catch is that the number on the outside must multiply into all the numbers inside at the same time. Like this. Which goes on to this. And finally this. Let's take a look at that again. We take the 5 times the 2, add that, which you know 5 times 2 is 10, add that to 5 times 8, which we know is 40. Add the 10 and 40 together to get 50. So, does it give the same answer, you ask? Yes. If it gives the same answer whether we add or subtract the parentheses first and then multiply, or if we distribute or pass out the 5 into the numbers inside the parentheses, then why would we use it? Well, what happens if you can't add what's inside the parentheses? Like this example, 5 times x plus 2. Then we're going to have to use the distributive property. Let's investigate more by going back through our note-taking guide. Example 2. You are buying beads for a craft project. You need gold, silver, and white beads. A bag of each type of bead costs $3.99. Use the distributive property and mental math to find the total cost of the beads. Well, you're right. We could do this the long way and multiply $3.99 times 3. However, you know the $3.99 is $4 minus a penny. That will get you $3.99. So then we can use the distributive property, 3 times 4, and then 3 times the penny, and subtract in the middle. 3 times 4 is 12. 3 times 1/100 is 300. And then what's $12 minus 3 cents? $11.97. That's the total cost of the beads. Here's a nice picture of how to distribute when there's addition and how to distribute when there's subtraction. You can see that we are passing out or distributing the number that's being multiplied, which in this case is A. This checkpoint, you need to use the distributive property to evaluate or solve the expression. Remember to use the distributive property. Do not just add the parentheses and multiply. Try to set it up using the distributive property because it is going to get harder when we put variables inside the parentheses. Pause the video and complete number 1. Pass out the 2 to the 9 and to the 4. 2 times 9, bring down the addition sign, and then use the 2 again times 4. 2 times 9 is 18, plus 2 times 4 is 8. 18 plus 8 is 26. Number 2. The 3 is the number on the outside of the parentheses, even though it's at the end. So that's what we want to pass out to the 12 and to the 3. So 12 times 3 minus 3 times 3. 12 times 3 is 36. Subtract 3 times 3, which is 9. The answer is 27. Pause the video, complete number 3. You can tell what number is on the outside because it's the one that's alone. There is no subtraction or addition sign in between that and another number. -4 is the number that's being multiplied. So we want to multiply it by 4. -4 times 4. Bring down the subtraction. And then -4 times 11. -4 times 4 is -16. Subtract -4 times 11 is -44. Remember your rules for integers. This is same, add, opposite. Keep the first number the same. Change subtraction to adding. What's the opposite of -44? Positive 44. The addition rules say that these are different signs, so I'm just going to subtract them. What was the bigger number? Well, 44, and that's now a positive. So your answer is 28. Evaluate the expression using distributive property and mental math in problems 4, 5, and 6. If you still are a little confused about how to do this using the distributive property, watch as I solve number 4. 5 is the one that's being multiplied, so inside the parentheses, I either want to subtract or add. To make it easier, I know that 100 plus 3 would make the 103. So now I can distribute the 5 to the 100, 5 times 100, plus 5 times 3, and solve that. 5 times 100 I can do in my head. 500 plus 5 times 3, 15. 500 plus 15 is 515. See how this problem was easier to solve now that we used the distributive property? Otherwise, you would have done 103 times 5. Try number 5 on your own. Pause the video. If you are having trouble setting up number 5, let me help. 4 times, well, I know that 3.8 is 4 minus 2 tenths. Pause the video and solve this problem using distributive property. 4 times 4, pass out that 4, subtract 4 times 2 tenths. 4 times 4 is 16. 4 and 2 tenths. 4 times 2 is 8. Bring down the 1 decimal point, so it's 8 tenths. And what's 16 minus 8 tenths? 15 and 2 tenths. Pause the video, complete number 6. 3 times, well, this is 6 plus 3 hundredths. Distribute out the 3. 3 times 6 plus 3 times 3 hundredths. 18 plus 3 times 3 is 9. Bring over the 2 decimal places. And what's 18 plus 9 tenths? 9 hundredths? 18 and 9 hundredths. Example 2. Use the distributive property to write an equivalent variable expression. This time we cannot solve for a single answer because of the variable, and we do not know what the variable is. However, we can rewrite this expression by distributing or passing out the 2 to the x and then 2 to the 10. So it will look like 2 times x plus 2 times 10. 2x you can't solve. So let's just bring down 2x, but I can solve 2 times 10, which is 20. Your answer is 2x plus 20. Part B. Here is the number that we're multiplying, so that's what we are distributing or passing out. Negative 4 times m plus negative 4 times 3. And again, the order does not matter. You could have rewritten it with negative 4m plus negative 4 times 3. 3 times negative 4 is negative 12. And that's your answer. Don't worry about this part. I will accept that answer there. C. Negative 3 times 2y. Bring over the minus, and then negative 3 times 6. Negative 3 times 2y. You can multiply 3 times 2, which is 6, and because of the negative, it's negative 6. Then we have negative 3 times 6, which is negative 18. Change this to same, add opposite, negative 6y plus 18. Pause the video and try 7 and 8 yourself. 7 is 4x plus 28, 8 is negative 12